Oh my goodness.
What? Oh, I know.
Alrighty.
Yeah.
Page, what page are we doing?
Is he mad? Sorry, I said bye.
Okay. Page 61 and 62. We're going to do graphing exponential functions. Alright. Graphing exponential functions. So, on page 61 is the notes that we're going to take today. 62 is the activity we're going to do on Friday. So, like this thing over here, you don't have that yet. But look, yum, Skittles. So, you can get excited about that. This is the one we're going to fill out today. So, exponential functions. This should hopefully look kind of familiar to you. And I didn't glue it on because we need the back as well. And so, you might want to just tape it on, or you can wait and tape it tomorrow. But this should look familiar because we did something like this when we did absolute values. So what we want to do is we want to take our function f of x equals 2 to the x power. We want to plug some values in so we can figure out what this graph looks like, because we really have no idea. And it's called an exponential because x is in the power and x is changing the power, and so that means the exponent is changing, so exponential. Makes sense? Maybe. So when I plug in -5, we're going to have 2 to the -5th. And if you remember our rules of exponents, we're not allowed to have negative powers. So this is going to change to 1 over 2 to the 5th, which is 1/32, which that's tiny. 2 to the -4th is next. So 1 over 2 to the 4th, so 1 over 16. 2 to the -3rd, it's going to be 1 over 8, because 2 to the 3rd is 8. So, oops. Yeah, 1/8. I don't know, I got lost. 2 to the -2nd, that's going to be 1 over 2 to the 2nd, which is 1/4. 2 to the -1st is going to be 1 over 2 to the 1st, which is just half. And then 2 to the 0, anything to the 0 is 1. Then we finally get into nice numbers. So 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd we got 8, 2 to the 4th, 16, and then 2 to the 5th is 32. So it's going to be really hard to graph all these. And looking back now, I almost wish I wouldn't have made a 4-quadrant system because I don't have any negatives really. I guess I have negative x's, but I don't have negative y's. Oh well, it's already there. So at -5, 1, 2, 3, 4, 5, I'm going to plot 1/32, which is really teeny tiny. So like right above 0. And then 1/16 is a little bit more than that. Then 1/8 is a little bit more than that. And then we're finally at, oh no, we're only at a 4th. JK. Now we're finally at half. And then 1. And then 2. So like if you notice, this graph is growing pretty quickly because it was like nothing, 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 and then now it's like jumping a lot. So when I get to 2, that's up at 4. 1, 2, 4. And when I get to 3, I'm up at 8. 1, 2. And then I can't really fit the rest of them on there. So like this graph was moving really slowly, and then all of a sudden it just took off. So I don't know, I kind of call the shape of that thing maybe a backwards L. I don't know. We can go with that. Why do you think it's shaped that way? Well, it's going to grow really fast because my exponents are getting bigger and bigger, which means I'm multiplying by more and more 2's. Like I'm always doubling something, and so it's going to start slow but grow fast. So then what we want to talk about is the general form of an exponential, which if you remember back again when we did the absolute value graphs, we had that y equals a absolute value of x minus h plus k thing. And like all those letters told me something about how the graph was changing. That's true of an exponential function as well, except there's no h and k. There's just an a and a b. And so those two things tell me about how the graph is changing. So if we choose 4 different a values, we're going to see how a changes the graph. So we'll pick like I don't know, 1, 2, 3, and then maybe we'll pick -2. Why not? See what happens when it's negative. And then what you might want to do is make the tables for them to see how I get these values, but I'm just going to get the values for you so that we can make this like not the most epic long video ever. So this first one, this first function, I'm going to do in red. So when I do 2 to the negative first, I get 1 over 2 times 1 is still 1 over 2. So right there. When I plug in 0, 2 to the 0, 0 times 1 is 2. Then when I plug in 1, we're going to get 2 times 1 is 2. And so this looks really the same as the last one, which if you look and compare this red graph to our first graph, they're kind of the same thing. That makes sense because we just times it by 1. If we do the next one in blue, we're going to times that by 2. So when I do to the negative first power, that's half, times 2 is going to be 1. When I plug in 0, that's 1 times 2 is 2. When I plug in 1, 2 to the first is 2, times 2 is going to be 4. Then when I plug in, what number am I on? 2, 2 to the second is 4, times 2 is 8. And so this graph, it kind of looks the same as the other one, except higher up. Like these all just moved up. Kind of by 2, I guess. Like it started at 2 and this one started at 1 and that just moved up. That moved up. So I don't know. Let's do the next one in green. So when I do 2 to the negative first, that's going to be half times 3 is going to be 3 over 2, which is 1.5. It's right here. When I plug in 0, 2 to the 0 will be 1 times 3 is 3. So right there. Look at that. That guy just moved up to 3. It's almost like we planned it. When I plug in 2 to the first is going to be 2 times 3 is 6. And then I don't think I'm going to be able to fit any other values on here. When I do 2 to the second, that's 4 times 3 is 12. So yeah, that's not going to fit. But again, it looked like it all just kind of moved up. They're increasing by the same amount. They're just like one is higher than the other. Then the last one that we have is -2. I'm going to do it in this darker blue color. So when I do 2 to the negative first, that's half. Times -2 is going to be -1. When I do 2 to the 0, that's 1 times -2 is -2. 2 to the first will be 2 times -2 is -4. And then when I do 2 to the second, that's 4 times -2 is -8. So this graph looks kind of the same, but flipped, which hopefully kind of makes sense. So how does A affect the graph? Well, this first red function kind of went through 1 on the y-axis and grew at a constant by 2 rate. Then this one, the blue graph, crossed at 2 and then grew at the same rate. The next graph, the green graph, crossed at 3 and then went up at the same rate. And then this one crossed at -2 and went down at the same rate. So A is affecting the graph by changing the y-intercept. And then if A is negative, then it flips the graph. So now we're going to choose 4 different B values, 2 integers and 2 fractions. So I'm going to pick 3 to the x and 4 to the x. And then I'm going to pick 2 fractions, so like half and a fourth. How about that? And then we're going to do those graphs to see how b is affecting the graph. So this one is b because it's being raised to the x power. And so now I just want to do 3 to the negative first. I'm going to do this one in red. So 3 to the negative first is going to be 1/3. It's pretty small. And then 3 to the 0 will be 1. 3 to the first will be 3. And then 3 to the second is 9, which isn't going to fit very well, but we'll pretend. So that one went through 1, but it's growing a lot faster because like this jumped up 2 spaces when it normally only jumps up 1 space. So now if I try 4 to the x, when I do -1, that's going to be 1/4, so that's smaller than 1/3. Then 4 to the 0, that's going to be 1. 4 to the first will be 4. And 4 to the second is 16, and that definitely won't fit. So like it started smaller, but it grew way faster because it jumped up above this red graph. Next we have our fractional power. So those ones are kind of weird. When I have half to the negative first power, negatives mean I have to flip it, which is what I've been doing here. It's like 1/3, 1/4. But now when I flip this half, that actually flips to 2. So half to the negative first power is going to be at 2. Then to the 0 power will be 1. Then half to the first power will be half. Half to the second power will be 1/4. So this actually like turned the graph around. Now it's not a backwards L, it's just a straight up L. Then we got 1/4. So when I do 1/4 to the negative power, that's got to flip the 1/4 to 4. So at -1, it's actually going to be up at 4. 0 will be 1. 1/4 to the first power will be 1/4. And then we're going to be at a 16th, which is really teeny tiny. But as you can see, this guy got flipped as well. He's just moving a little bit faster than the 1/3 or the 1/2 was. So how does b affect the graph? B is making it go faster, slower, or if it's fractional, it's flipping it around. So faster or slower or flipping to a straight up L, not a backwards L. If you turn the back here, describe what you've just learned about each variable. You can try this out and tell me what you think about A and B, and then try graphing these two. We'll do them in class tomorrow, and then we'll go over some more graphing stuff. So that's it. Peace out.